All right, a determinant is simply a difference of the products of the entries along the diagonals of a square matrix. And so in order to do a determinant, you have to have a square matrix, meaning the rows and columns have to be the same number. So 2 by 2, 3 by 3 is pretty much what we're going to be using in this section. And if you evaluate the determinant, again, the easiest thing to do is just to use your calculator. So let's take a look at a set. So let's start with a 2 by 2. Right, so the actual determinant itself, in a 2 by 2, it winds up being an easy calculation, although, again, I'd still recommend you use your calculator. But what you're going to do is you're going to take the product of the diagonals and take their difference. So the determinant itself would just be 3 times 4 minus, and then the other diagonal, 1 times negative 2. And so that's going to give you your overall determinant. And so you would get 12 here, and then minus a negative becomes a plus 2, which winds up giving you 14. So if you had to evaluate the determinant, that's all you need to do by hand. And now you can use your TI-89s for this. So if you're going to use your TI-89 to find this, the first thing you need to do is access the math catalog. The math catalog is located here by hitting the second function and then the number 5 key. So if you hit second, number 5, it opens up this math catalog. And then if you scroll down to number 4, in here it says matrix. And then click to the right and you'll see DET. And so that's how you can use your calculator to access the determinant. And then you simply enter the matrix from that. So you would enter this as the determinant of, and then enter your matrix. Commas to separate columns, semicolon to jump to the next row. And that's how you would evaluate it. So if we type this in, so access our matrix, enter 2, negative 3, semicolon to jump down to the next row, 1, comma 4, close off our matrix, and then close off the parentheses that is evaluating the determinant. And when you hit enter, it confirms that 14 is, in fact, the correct answer.